Good job, everybody. You are C students or better. Congratulations. All right. So let's continue talking about stack machines. Actually, time permitting, this may be the last day that we talk about stack machines. And then the next big thing to talk about is Turing machines, which is kind of the, in my opinion, the high point of the course, and it's what we will be talking about for the rest of the semester. But one last day about stack machines. We were discussing stack machines versus grammars. Right? Stack machines versus grammars. And there are kind of two sides to that story. One is, can you convert a stack machine into a grammar? And the other is, can you convert a grammar into a stack machine? And actually, we did the grammar into a stack machine. So last time we talked about a context-free grammar can be converted into a stack machine. And it's an easy procedure to do. You just have to remember how to do it. Here, I will just give us another example. For example, everybody's favorite context-free grammar, S goes to A, S, B. Just to make it interesting, I'll say or A. Actually, my favorite is when it goes or epsilon. But if you say or epsilon there, it gives you the language A to the N, B to the N. This gives you, I guess, A to the N plus 1, B to the N. You just have one extra A. Anyway, can we convert this into a stack machine? So I hope you remember, and if you don't, you can just flip back in your notes one page. Converting this into a stack machine, it's, like I said, it's easy to do. You just have to remember how to do it. How to do it is every grammar arrow, of which there are two in this example, S goes to ASB and also S goes to A, they become epsilon reads. So this will say read epsilon, pop S, push ASB, and also read epsilon, pop S, push A. So each arrow just directly becomes a row in your stack machine with a read epsilon, and then you pop the thing on the left of the arrow and you push the thing on the right of the arrow. And then, in order to make this work, you also need special rules which just say AA epsilon, BB epsilon. If you had C's in there also, you would put CC epsilon, and so on. And that's it. This stack machine is equivalent to the original grammar. And if you wanted to do a derivation on the stack machine for a particular string, you would first derive it using the grammar and then try to match those same steps on the stack machine. So, for example, if I want to, how about let's derive AAABB, all right? So first I would do it on the grammar. This would say I would go S goes to ASB, and then do that again, AASBB, and then finally S goes to A, AAABB. All right, so that was the grammar derivation. I should, just to be technically correct with my arrows, that's the way they would have done it in the book. All right, that's the grammar derivation. I'm going to try to do those same steps more or less in that same order on the stack machine. So on the stack machine, I start with the whole string, AAABB, comma S, and using the arrow that looks like that, I'm going to do the same steps. So the first step that I did on the grammar was S goes to ASB. That is rule number 1 on this stack machine. It's an epsilon read, so I leave the string like it is, AABB, comma, and now S changes into ASB. All right. Next, on the grammar derivation, I did one of the other grammar steps, but actually you don't do that yet. You have to do sort of intermediate steps when you're doing the stack machine to read this A and pop this A. There's no other rule you can do here with a little a on the top of the stack. The only thing you can do with a little a on the top of the stack is this line, A epsilon. So that has the effect of clearing A from the input. So now the input just says AABB, and also clearing A from the stack. So now it's SB like that. That was, if you're counting the steps here, that you don't have to write the numbers if you think it's all obvious, but just for clarity, that was rule number 3. All right, and now I am ready to do my next grammar step, which is rule number 1. This is an epsilon read, so I leave the input the same, and now S becomes ASB, so it's now ASBB. All right, and then again, I do number 3 to clear the A's from the input and from the stack. Now it says ABB, comma, SBB. Right, now I'm ready to do another grammar step. And you could do the ASB one again, but you shouldn't, because I'm following along these same grammar steps here. I'm at this point now, which is S goes to A. That's what's going to make it all work out. So I'm going to do number 2 at this point. That's the rule that came from S goes to A. So it's now going to say ABB, and now S becomes A, ABB. And then you just do 3 and 4 a few times to get rid of everything, and you'll end up with empty string, empty string. So first I do number 3 to pop those A's, B, 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 B. Next, number 4 twice, I guess, to pop the B's, B, B. And finally, epsilon, epsilon. The end. All right. Any thoughts about that? This, I would describe this as pretty easy. You just have to know what to do. There's not really any surprises. I got one for you all to try, if you would. I give you a grammar. Make me a stack machine that's equivalent to this grammar. S goes to ASC or AS or BS or epsilon. This is a little weird. Now, it's actually not necessary that you even try to think about what kind of a language will this actually make for you. You can do all of this. So your job is convert to stack machine, stack mac, and show a stack derivation for A, B, A, C, C. Try that. Feel free to chat with your friends if you like.
Add this one.
It should say epsilon S epsilon.
Oh, my bad, yeah.
So that you do. You would never epsilon just doesn't do anything at all. So you wouldn't need that. All right. Looks good so far. Yeah. I think you need a rule for this part. Oh, you wrote some words. Oh no, that was the question. It says S goes to epsilon, so you can do a rule in that style.
Got it.
You do actually need it. Doing okay? Mm-hmm. Yes. Yeah, you always need these guys.
And so since there's a C, you also do a percent.
Mm-hmm. All right. Okay. Doing all right. when you're doing your stack derivation, it's probably a good idea to derive it on the grammar first so that you know which steps to do. And then copy those steps in the same order.
Yeah.
You have to think a little bit to make it work in the grammar. All right.
These ones are always in the epsilon. Yes. Like this first one, the greater than s goes to as, should say epsilon plus as.
Oh, so, should say yes.
Yep.
Oh, that should,
Okay. Yeah.
just like this. No.
Yeah, I think just different ones. Because this is. Yeah, think about doing this on the grammar first, and then that will tell you which steps to do. All right.
Yeah, these you always do this one s. So put as c. This one s goes to as. And then it's the same with that. You just
All right.
about this. There are 4 different rules here.
Still doing good? I'm going to start writing my answer here. Are we ready to discuss them? I see some people still working on it, which is fine. Writing down the rules for the stack machine is pretty formulaic. As long as you know what you're doing, you just do it. Make sure you don't forget. There is a rule s goes to epsilon, which you may be tempted to just say I don't need that one. Actually, you do need that one. So you do need a rule that says epsilon s epsilon in your stack machine. Although when you derive this particular word, yeah, you need to use it. In the last step, s becomes epsilon. At least. Anyway, to derive this word, this is slightly tricky just because it's a weird grammar and you have to figure out how would you even make that word, that string, using this grammar. And here is how I would do it. I had to think a little bit, but I would go s goes to ASC first, and then this s becomes BS because I need to put a B right there after the first A. And then I go ASC again to put 2 C's at the end. And now I'm almost there, but I want one more A without getting another C. I go S goes to AS here. and then S goes to epsilon, and that's how I get my string A, B, A, A, C, C. And now I'm just going to mimic those same steps on the stack machine, and in between you have to do some of these steps down here. By the way, I hope you didn't forget C, C, epsilon, because there are C's in this language. You need, A's and B's and C's. Every letter in the alphabet has to be listed in there. So on my stack machine, it would look like A, B, A, C, C, comma, S. Unfortunately, when you actually write this out, there's kind of a lot of steps. But first I'm going to do the rule S goes to ASC on the grammar, which is rule number 1 there. So it's now going to say A, B, A, C, C, ASC. And now I pop the A's, which are at the beginning of the string and at the beginning of the stack. B, A, A, C, C, pop the A, it's now SC. All right, and now I want to put a B on the stack. S goes to BS was my next grammar step, so I'm gonna do on my list, it's the third rule listed. It's now gonna be B, A, A, C, C, B, S, C, and then pop the B's, A, C, C, S, C. Right? And now I do, the next grammar step that I did was another S goes to ASC. So that's what I'm going to do. Rule number 1, AACC, ASC, C. And now pop the A's. It is ACC, SCC. Now I'll go S goes to AS on the grammar, which is rule number 2 in my list. So this is ACC, ASCC. Pop the A's. CC, SCC, and now I do S goes to epsilon, which is rule number 4 on my list. Pop S, push epsilon, so this is now CC, CC, and now I just pop the C's twice. C, comma, C, and then epsilon, epsilon. There you go. I think probably your stack machine derivation should be exactly the same as mine, although I suppose there is some opportunity for doing things in a slightly different order, but probably it should be the same. Yeah?
For the one you did above for the derive,
Yes.
is there multiple ways of doing it?
There are, but there's not many. I think these 2 steps that I did, you could have done those 2 steps in the opposite order.
Yeah,
Is that what you did? Yeah. I think actually that's the only other alternative way that you can derive this one. All right. Great. I hope that this is clear to everybody. If you practice it a few times, there's not a lot to it. We got 20 minutes left. I think we can talk about, one more thing to say about this. I said, I don't know if anybody noticed or cared, I said you can do, by this method, convert any context-free grammar to a stack machine. What is important about context-free? Does this have anything to do with context-free? First of all, can anyone remind us, what does context-free even mean for a grammar? This is a specific type of grammar. Basically, every grammar we ever talk about is context-free. Anyone remember the definition? Nobody. I'm going to give you all D's now. Send a note to your field hockey coach, whatever. That's what I'm supposed to do.
How do you know we have one?
Yeah, I assume most of you do not have one. Maybe none of you.
We actually do.
You do? You have a field hockey coach?
The mirror team does.
Okay. I got to get on that then. You remember?
When the left side only has one non-terminal.
Yes, thank you. That's when the left side of the arrow only has one non-terminal symbol. All right? No funny business. Now, technically in a grammar, you are allowed to put more complicated stuff over here. It's just we never do because that makes the grammar, in my opinion, very confusing and very complicated. Context-free grammars are a lot easier to think about, a lot easier to talk about. They are when the left side of the arrow has only one non-terminal letter. And why is that important for this procedure? It's just because if there was some weird funny business on the left of the arrow and you did this procedure to it, you would end up putting that stuff in the pop column, and that is not allowed in a stack machine. The pop thing is only allowed to pop one thing off the top of the stack. If you allow the pop to pop many things off of the stack, then really you're not treating it like a stack anymore. If you allow that, this would allow you to somehow reach down deep into the stack by popping off several things at the same time. And that is sort of violates the spirit of what a stack is all about, which is to say you should only be looking at the thing on the top. Pushing stuff onto the top, many things onto the top, really is still treating the stack like a stack. You're still modifying the top of it. But if you pop many things off, that's equivalent to reaching down deep into the middle of the stack, which is not allowed. So anyway, that's why context-free is important here. So I'm just going to say this whole trick here, this only works for a context-free grammar. That's because since the pop column is only allowed, what happened? Microsoft Auto Update. Sorry, cancel. Don't do it. The pop column is only allowed to have single letters in it. All right. And so what this says is any context-free grammar can be converted into a stack machine. A non-context-free, perhaps cannot be converted into a stack machine unless you have some tricks to rewrite it into a context-free. All right. What about the other way around? Can you convert a stack machine back into a grammar? And the answer is yes. And in this is just another fairly simple procedure that you have to see once, but once you understand how it works, and provided you can remember how to do it, it's really easy to do. So I would like to talk about the other way around, stack machine converting into a grammar. This is also easy to do once you know how to do it. And I'm just going to tell you sort of how to do it, and then we'll talk about why it works. This one I think is not quite obvious why it works, but it does. Here is an example of a stack machine. This is the stack machine. We talked about this yesterday. All strings where the number of A's equals the number of B's. It was a little complicated. Read, pop, push. In my opinion, this converting a stack machine into a grammar is kind of magical because it's not at all obvious why it works, but that's something for us to discuss. Anyway, here is the grammar. We talked about this yesterday. The idea, remember, is X indicates extra A's rather than if you're keeping track of how many A's there are versus how many B's. An X on the stack indicates an extra A. A Y on the stack indicates an extra B. That's why an A sort of cancels a Y, but an A doubles a X. And then as far as B goes, this BS line is just for if the first thing you see happens to be a B, you have to add a new Y on. If you see B and X, they should cancel. If you see B and Y, you should get another Y. And then there's just to get rid of the S, there's a epsilon S epsilon rule, which you only do really at the end. All right, so that's the stack machine for the language where the number of A's equals the number of B's. Here's how we convert it into a grammar. The whole trick can be summarized right here in this box, and this, I suppose, eventually you should remember, or you should memorize, but it's easy enough to do. If you do a few examples, I think you'll remember. If you have a rule that says read X, pop Y, push Z, whatever those are, this becomes, in your grammar, Y goes to XZ, and that works. Why does that work is a question to discuss at length, but it's easy enough to do. So this whole thing, when I convert it into a grammar, you just read line by line, and each one of them you do Y goes to XZ. So the first line will say S goes to AXS. Next line will say X goes to AXX. You don't really have to think to do this. y goes to a. That's a followed by epsilon, but that's just a. Next one says s goes to bys, x goes to b, y goes to byy, and finally s goes to epsilon. All right, and that is the grammar. Sorry, those y's look kind of like t's. There's no t's. They're all y's. All right, that's it. This is how you do it. Very simple procedure. Now, this is a somewhat strange way to write a grammar. More typically, I would sort of simplify or consolidate here. I would write this as x goes to axs or bys or epsilon. So I'm just sort of gathering together all the ones which have a s on the left side and putting them together as a single line. This is more typically how we would write this. Similarly, I will do x goes to axx or b, and then y goes to byy or a. All right? This is the grammar, which is equivalent to that stack machine. I want to try to get a feel for why this actually works. It's very easy to do. And I think it might be helpful towards that end to just look at a sample derivation here. So let's derive, how about ABBA? And I want to try and compare step by step the stack derivation compared to the grammar derivation and see if we can kind of see any similarities or whatever. So on the stack, I'm going to try my best to write this all on one line. I don't know if it's going to work out, but I'm going to try. So I begin with the whole string to begin with, followed by s. And now I'm going to go, so I read A, and this stack machine is fairly unambiguous. I think you basically have to do the steps in one particular order. You could do the last step at this point, but this last step is only going to happen at the very end. So I'm going to do rule number 1 there, ASXS. So this is read the A, and then S becomes XS. All right, next I go read the B, pop X, push epsilon. So this now says BAS. Next I have a read B, pop S. So that will become YS on the stack. So this now says A, comma, YS. And then next I have read A, pop Y, push epsilon. This becomes epsilon S. And then finally I do the rule at the very end, which gets me down to epsilon, epsilon. All right, that was the derivation on the stack. Let's try and write out the derivation on the grammar and see if we can see any kind of similarities and differences, as the kids say. So on the grammar derivation is kind of like the opposite of a stack derivation in the sense that on the stack derivation you begin with the whole string and you sort of eat it up one letter at a time until you get down to nothing. Whereas the grammar derivation, you kind of begin with nothing, you just begin with S by itself. And then step by step, I'm going to create the letters one at a time until I end up with ABBA. And how would I do that? Well, to get an A at the beginning, I want to do the first step here. S goes to AXS. So that's what I'm going to do. AS. Yeah, so now it says AXS, right? And maybe I probably should have done this before. If I write the numbers, I like to say numbers like numbers. It's because I once saw an interview on TV with like a former mafia hitman, and he had appeared as a witness testifying against his former boss, who he had shot a bunch of people on their behalf, but he got off because he ratted on his boss. And the interviewer said, like, aren't you guys not supposed to aren't you not supposed to rat on each other? And he said, no, I'm not a rat. A rat is when you tell the police in secret. I testified openly. I didn't know that there was such a distinction. But he said these guys, they all know me. They know where I live. They've been to my house. So, if they got a problem with me, They can come and take me out if they want to, but they better come in numbers. That's ever since I heard him say that word. I like saying it like that. Anyway, that was my little story about why I say numbers. All right, I will have you notice the grammar step that I did first is the same step that I did first on the stack derivation, right? The stack derivation began with rule number 1, and I did that same rule again. And then next on the stack was a read B pop X, which is rule number 5. But that is also what I have to do here. In order to put a B here, I have to change the X into a B. All right, I'm going to do that rule also. So this now becomes ABX. All right. And then what's next? On the stack machine, I did BAS. So this was a read B pop S. That was rule number 4. S became YS. And I'm also going to do grammar rule number 4 here. S becomes BYS. So this now says ABBYS. What? Oh, sorry. This should be a S here, right? That was a typo. All right. That was, and this arrow should be the grammar type arrow. This is grammar rule number 4 also. The same step that came from stack rule. Is it 4? Yeah. Stack rule number 4. All right, and then the next stack rule that I did was read A, pop Y, push epsilon. That was rule number 3, and I'm going to do the third grammar rule. Y becomes A, B, B, A, followed by S, and then finally S goes to epsilon, which again is a copy of the stack rule. It now just says A, B, B, A. All right. Can we explain in our remaining 5 minutes why this actually works? So one thing you can notice, I'm doing exactly the same steps in the same order, which should suggest to you there is some kind of deep hidden relationship between these rules over here and these rules over here. They're both expressing the same types of actions. How exactly can you see the connection? I would say something to notice in the grammar derivation is we have these letters here, A, AB, ABB, ABBA, and ABBA. Those somehow match with the string, the portion of the string on the stack machine which has already been read. So they kind of match up with this. I hope that this is making some kind of sense here. They're sort of complementary in the sense of like the opposite, right? Here I have no string at all, and here I have the whole string. Here I have only the first letter. Here I have actually everything except for the first letter. Here I have the first 2 letters. Here I have the last 2 letters, and so on. So these are, they look different from the stack to the grammar. They are actually kind of the same. It's just sort of like the opposite. The stack machine, every step you write down what is remaining of the string to create, whereas in the grammar, every step you write down what I have already created from one step to the next. All right, so could I say, and I will have you notice also, check it out, these, what you see here after, the blue part, do they look familiar from the previous line? The answer is yes. Actually, they are exactly equal to the stack that you see from one step to the next in the stack derivation. So really, what we see in the grammar, so each grammar step, I would say, each grammar step looks like you have some part here, which I underlined in blue. This is the part of the string which is read so far. If you're thinking about the stack derivation, these blue guys are the same as what has already been read from step to step on the stack derivation. All right, so that's sort of the blue part, and then followed by the stack. Right, that's sort of the green part. All right, each grammar step you can just break it down into 2 parts. The first half of it, or the first part of it, is the letters which have already been read from the string. And then the second part of it is the stack. All right, and so a stack rule, like, if I have read, pop, push. If it said read X, pop Y, push Z, what should happen when I do that stack rule? In this case, if you want to do that rule, it means that the stack has to have a Y on the front of it. So this applies when the stack starts with a Y, right? In which case, you know, this thing actually looks like, again, the string which is read so far. If you're going to do that rule, it means there's a Y right there, and then followed by the rest of the stack. All right. And what does it look like afterwards, after you do this step? So before you do this step, if you're going to do this step, it has to look like that, right? And then what is it going to look like afterwards? This becomes, when you actually do that step, what happens to the string which is read so far? It's that same thing, but now you also just read the X in one step, right? Because that's what this step is. It's a read. So after you do this step, the X joins in with the original string which was read so far, and the Y which was on the stack is thrown away and replaced by a Z. So now it looks like this. And this, my friends, is why the grammar rule Y goes to XZ is the appropriate thing to do. Because when you do one of these steps, the Y which used to be on the top of the stack is actually a Y sitting in the middle of your grammar word. And if you do it correctly, it should turn into XZ. So this is why Y goes to XZ works. All right. If you weren't paying attention the last 10 minutes, you can just memorize everything, and it will still work. But I thought we should discuss why. All right. I think that'll do.